Well, Tim, thank you very much for your kind words. I'm going to speak on behalf of our air pollution epidemiology group in the environmental research group. You see the members here. What I'm going to try to say is how epidemiology contributed to the trajectory from when we first discovered that high air pollution levels were detrimental for health to today's knowledge. Okay, so where are we now is a snapshot I want to give you before we start. Actually, these are the very recent September 2021 air quality guidelines issued by the World Health Organization. And just have a look here for PM 2.5. The recommended annual levels are annual concentrations are at 5 micrograms per cubic meter, the 24-hour ones at 15, for PM10, 15 and 45 respectively. For NO2, 10 and 25 respectively. How did we get here? I want to claim that this was a successful scientific trajectory and that there was a major contribution from epidemiology. The scientific trajectory started yesterday here, but the contribution of epidemiology is going to be my focus in this talk. So we go back to 1979, in fact. And there was a supplement of the American Journal of Epidemiology edited by very prominent British scientists and who claimed, as you see in the red frame up right, that the judgment in this area depends much more on the art of epidemiology than anything else. And they recommend levels for, it's not PM 2.5, it's something different but similar to, of 140 micrograms, you see that, but only in the presence of sulfur dioxide of 180 micrograms per cubic meter. And this is for sensitive subgroups and transient health effects. And then for more serious health effects, 250 micrograms per cubic meter of black smoke and 500 of sulfur dioxide. Very high levels. Did they really have the evidence and they were judging it maybe in a one-sided way, or was the evidence not there? Actually, these conclusions were disputed by American scientists like Carl Schei, who defended the 1971 US air quality standard, which was as high as 75, but lower than 250 or 500. And he responded to Holland and the colleagues, pointing out the importance of epidemiological studies and giving a slightly different point of view for the evidence that was there at that time. Some evidence started to accumulate meanwhile, but still, 10 years later, in 1990, in a meeting where I also was part, a report of WHO for that meeting actually said that severe short-term effects happen above 400 and 500 micrograms per cubic meter, and this is about daily concentrations. So not much had changed in those 10 years. We're still talking about 10 times higher pollution levels than we are talking today. Then evidence started accumulating from a type of epidemiological study, the time series studies, which actually had many advantages and soon led to accumulated evidence which couldn't be much disputed about the short-term exposures and their effects on mortality and morbidity outcomes. What's good about time series studies? They are actually cheap because they are based on routinely collected data. They are very powerful because you can have daily time series across a very large time period, 10 years, 15 years, 5 years. They give very powerful statistically results. There is limited problems of confounding with this study design. We now have a very wide geographical coverage exactly because these are easy and based on routine data. And actually, they really made a significant difference with people realizing that air pollution could cause adverse effect at these so-called lower levels. And lower levels were those compared to the, for example, London 1952 episode, where the levels of pollution were up to 4,000 micrograms per cubic meter concentrations, something that was out of the reach of these lowered concentration levels. Here you see on the right-hand side two results from a multi-city time series studies. One was a European one that was quite influential at that time. You see with several cities, the pooled relative risk is very statistically significant and above 1. And the other one is from a corresponding study in the US, which was published in the New England Journal of Medicine in the year 2000. Time series studies really increased for the reasons I mentioned. You see on the left panel how much of a steep increase there was until this year today. They are still published. And on your right-hand side, you actually see a result of an analysis that was published in the New England Journal of Medicine in 2019 and includes data from 652 cities, showing a monotonic dose-response curve going down to almost 0 for PM2.5 and mortality, and with really very narrow confidence intervals. However, the type of study that really made the difference were the cohort studies. Cohort studies are studies that are the best design that you can have in an observational epidemiological study. Needless to tell the audience here that it is extremely difficult to have experimental studies for air pollution exposures, because that would mean to expose people to an environmental factor that we think is detrimental for health, and that's unethical. It's also not feasible, but there are major problems. We can only have experimental studies for secondary hypotheses, which will consolidate the epidemiological evidence coming from observational studies. So a cohort study is the best study design you can have in an observational study. And they started to accumulate, and they really made a difference, because the impact of chronic effects of air pollution for such a widespread exposure that covers the whole population is related to very serious numbers of events, impacts, and so on. So the first studies that were mentioned yesterday were first the 6-city study, and secondly, the American Cancer Society study. Now, in the right-hand side in this histogram, you see for various European cities, the blue bar is the impact from long-term effects of pollution. The red bar is the impact of medium-term effects, like 1 to 2 months. And the yellow bar is the impact of short-term effects from the time series studies. So you see that by far the largest impact comes from long-term exposures. This is what makes the cohort studies important. Here you see on the left-hand side a very famous graph from the 6-city study, which shows that with PM2.5 exposure, mortality increases very linearly from the cleanest city to the most polluted city, Steubenville, Ohio, for which there are also many relevant publications. Actually, there is a recent 2022 paper which says beyond Steubenville. So it's a landmark. And on the right-hand side, you see similar results coming out from a larger study, the American Cancer Society study, which was based on 151 cities. However, exposure assessment in these initial cohort studies was very elementary compared to what we have today. So now I go back to the 2021 WHO Air Quality Guidelines to say that actually their summary starts by declaring the global burden of disease associated with air pollution exposure exacts a massive toll on human health worldwide. Exposure to air pollution is estimated to cause millions of deaths and lost years of healthy life annually. The burden attributable to air pollution is now estimated to be on a par with other major global health risks, such as unhealthy diet, tobacco smoking, and air pollution is now recognized as the single biggest environmental threat to human health. So we really arrived at a consensus that air pollution effects on health are really a major threat. Again, the first column of this table is what I showed you before. The next column that is added here shows the 2005 air quality guidelines, which were the previous ones. And in the panel on your right-hand side, you see how much decreased are the levels of PM2.5, PM10, and NO2, that there is a new limit for ozone that was not there before, and that this, to a large extent, is due to the contribution of epidemiological studies, as I tried to briefly delineate. However, after these air quality guidelines of less than 2 years ago, we actually have accumulating evidence that warns us even more. So the Health Effects Institute has funded 3, the so-called low-level studies. One is in Europe, one in Canada, and one in the US. You see here who are the coordinators, and you also see on the left-hand side what are the mean long-term exposure levels in terms of PM2.5 in these 3 areas where the studies take place. And what do we see here? This is from the European ELAPS project, which is coordinated by Bert Brunnegraaff in Utrecht. This is from a paper in Lancet Planetary Health in 2022. It shows the significant associations with PM2.5. The hazard ratio here for mortality is 5% per 5% increase per 5 micrograms per cubic meter increase in the annual levels. For NO2, it's comparable, and here is also an estimate for black carbon. The associations are steeper at lower concentrations, and for PM2.5, they go down to 5 micrograms annual concentrations, and for NO2, practically to 0. There. This is a slide that is comparable from the MAPLE project in Canada. It comes again from a 2022 publication, and in Canada, actually, air pollution is even lower than in Europe, and you see the effects going down to 2.5 micrograms per cubic meter with very narrow confidence intervals. There is also new evidence that indicates important effects on other than respiratory morbidity outcomes. I'm not going to concentrate on respiratory morbidity outcomes here because they are well known, and I think we all have heard evidence on that. But other than respiratory morbidity outcomes, some very interesting ones. So cognitive function decline in children and adults is associated with higher air pollution exposure, long-term exposure. Cardiovascular outcomes associated with both long-term and short-term exposures, including stroke, ischemic heart disease, MI, atherosclerosis, arterial stiffness, blood pressure and hypertension, arrhythmias, cardiac arrest. So much more common morbidity outcomes. Reproductive outcomes and effects in early and later childhood, and several cancers. Briefly, this is a result from a recent meta-analysis, 2023. It's from Imperial College, basically. It shows that air pollution is related to accelerated cognitive decline if we take collectively recent publications on that matter. The second graph on the bottom shows that air pollution is related to the incidence of dementia, and these are the well-designed studies in this meta-analysis, also a 2023 publication. It shows 42% increase in risk, not trivial, also statistically significant. Here you see another publication is a systematic review of all meta-analysis, what we call an umbrella meta-analysis. Consideration of all the evidence, and you see assessments of where we have sufficient evidence for morbidity, for cardiovascular morbidity and air pollution exposure to PM and NOx's. And here you see about reproductive respiratory outcomes in children. And here we are not talking about asthma exacerbation, which is a result of short-term exposures. We are talking about asthma onset, new asthma cases due to long-term exposure to air pollution. And you see that there is moderate to high evidence for asthma onset, and moderate to high evidence for acute lower respiratory infections. This is the fourth line here on the table. You see that these increased risks are associated with NOx exposures, with elemental carbon exposures, and PM2.5. So there is new pollutants and new outcomes here. There is consistency across the outcomes, and there is consistency across the pollutants. And here you see new cancer outcomes. Okay, the left-hand graph is a meta-analysis from the ESCAPE project, and this is from Lancet Oncology and actually shows evidence on lung cancer increase with increased PM2.5 and PM10 exposure. This paper now has nearly 2,000 citations in the international literature. But on the right-hand side, you actually see new publications. Most are from 21 onwards on the association of air pollution exposure with liver cancer, bladder cancer, breast cancer, and there are few more. And actually some of these publications have been led by Zoran Andersen, our next speaker here. So this is just some examples. Environmental equity was the objective of a presentation yesterday, so I won't talk much about it, but there are epidemiological studies addressing the environmental inequity in exposure, which is something that we know more about. But actually what is more important from the epidemiological point of view is that the people who are more exposed because they are more deprived, they actually also share other vulnerabilities. They are sensitive because of other reasons. Therefore, there are multiplicative effects. What you see on the graph here is from a Canadian study, which shows that air pollution exposure is larger, greater, when people have a lower income. And in this publication, you actually see air pollution exposure within metropolitan areas. Here you see London, it's the right bottom city. You actually see there are exposure contrasts. These inequalities in exposure are associated with population density, the percentage of the population born outside European countries, crimes per 100,000 inhabitants, and with unemployment rate in this particular publication. Another important objective of epidemiological research is the interaction between air pollution and climate change-related exposures that were mentioned before by Virginia Murray. For example, heat waves, and other climate change-related factors that I'm going to refer later. Here you see results from the Exhaustion project, which is a Horizon 2020 European project. So what do you see? Look at the little table there. It comes from the graph. Actually, it summarizes the graph. It shows that the heat effect on cardiovascular mortality in this example is lower when you have low air pollution levels, and pollution is defined as PM10 concentrations here. So at low pollution levels, the heat effect results in 0.4% increase in mortality per day. When the exposure to pollution is medium, 2.6% increase. And when the level of pollution is high, actually we have an 8% increase. Therefore, there is synergy between heat, hot temperatures, heat waves, and the level of pollution, which is very interesting if we consider the recent changes and what we expect. Another issue that is also important is that we are having new discussions on methodological problems. For example, here you see that when we have measurement error in exposure, which is very common with air pollution, because it is extremely difficult to accurately measure the exposure of an individual to air pollution of ambient origin. So when we have larger measurement error, what happens is we get biased effect estimates, and the bias goes towards the null. So we actually underestimate the air pollution effects on health, and we underestimate them more with long-term exposure studies in the cohort studies. So there is less underestimation in the time series studies, one other advantage of time series that we should keep in mind. And there is quite a bit of underestimation, up to 50%, maybe sometimes more, depending on the type and the magnitude of measurement error. Also, it is extremely important to discuss the interactions between environmental factors, air pollution in our case, and COVID-19 outcomes and other infectious diseases. So actually, there have been many hypotheses for interactions, and due to the urgency with the COVID pandemic, many low-quality studies have been published. So we are in need of well-designed studies here for an important topic. So one plausible hypothesis that we think also has some evidence supporting it is that long-term exposure to air pollution, to higher pollution, turns populations more sensitive to the effects of an infectious disease like COVID-19. And there is some evidence on that. You see the graph here. It actually shows that individuals who were more exposed to air pollution, this graph comes from cohort studies with individual level data. And actually it shows that you get worse COVID-19 outcomes. This is about COVID hospitalization, but you can see several outcomes if you look at the literature. So there is a synergy between long-term exposure to air pollution and COVID outcomes once you are infected with SARS-CoV-2. And there are other things in this area that need to be better studied and defined. So we know a lot. What are further needs and gaps in knowledge? Okay, improvements on individual and population exposure assessment for use in epidemiological studies, including emissions, modeling, and more and better measurements of new pollutants like black carbon, elemental carbon, or ultrafine particles, and source apportionment. All these issues were touched upon yesterday. Understanding the effects of less studied health outcomes, as I tried to demonstrate. Understanding environmental inequality and promoting relevant policies, evaluation of the effects of biases, including measurement, error, and misclassification bias, synergies between exposure to air pollution and climate change, interactions between exposure to pollutants and other environmental exposures, and interactions with infectious diseases. Now, we are the air pollution epidemiology team, as I mentioned. Here are the members of the team, Dimitris Evangelopoulos, Sean Lee, Heather Walton, and Dylan Hood. And also, I would like to mention that we actively collaborate and draw on the expertise of ERG visiting professors, Francesco Forestieri and Michal Kryzanowski. Our group works in research, so several of the evidence I showed you throughout my presentation actually comes from projects that we have led or contributed as members of the group in the previous years. But we also do health impact assessment, that is, we translate epidemiology into policy, and this is going to be the topic of the next talk today. Here I want to show you that actually a lot of health impact assessment and translation into policy was done under the leadership of Martin Williams and continues today. And Martin Williams was the co-chair of the WHO Air Quality Guideline Group until his death in 2020, before the guidelines were publicized. He had many publications with many across ERG groups. And just two examples are here below. The one, the Lancet Countdown, was actually highlighted yesterday as well. Here is an example of a few of the reports that our group has contributed to or led. The left one is about the interaction between air pollution and COVID, and some were showed yesterday by the modeling team. It's a collaboration between groups in ERG. And my concluding points, this is the last slide. I wanted to persuade you, and I hope I did to some extent, that epidemiology has greatly contributed to the consensus that we have achieved on the importance of air pollution exposure for health. Our team and its members have been part of this trajectory for several years. Health impact assessment has been an important part of our team's work, linking epidemiological findings with policy. A lot of epidemiological evidence is consolidated like I think I showed, but there are still open questions, and future work should focus on interactions between pollution, climate change, and other environmental exposures, as well as environmental equity and methodological advances. Thank you very much.
Thank you, Claire. We have 2 minutes for 2 questions.
I started 2 minutes late.
Can we get a microphone across there, please, if we could? Maybe just pass over the back.
Hi, I'm Nikki Lang, Director of Public Health for Hammersmith and Fulham. One, I'll ask for your slides later because one of them would be very helpful for our residents. We're getting a lot of pushback on our clean air work with people saying things, and it was even in the Telegraph this week. Since there have been huge gains in reduction in air pollution, why is everyone going on about it? Why do we still need to do more? So I think it comes back to what you and Prof. Murray are saying. How do we get the translational bit in of translating the science into why we need action now? And we work very closely with Frank and Ben. I think the next step is, obviously there's clear scientific evidence. It's just from a public health point of view, how do we translate that into clear, easily digestible messages so that we can sort of dispel these myths and not see media reports of, oh, air pollution is so much better than in the 50s, we don't need to do anything more. So it's more like a challenge that we grapple with at a local authority level all the time, and how do we sort of counteract these, I don't know, negative myths or whatever. So thank you, and love the slides.
Well, I think, this is going to be the objective of the next talk, but I wanted to say that some of the evidence is really persuasive. You can actually employ it. Some of these graphs, you can explain them in simple words. I mean, we also, I don't mean we personally, but scientists didn't expect to have effects at such low levels, but they see them, and they are undisputable. I mean, they are we are very certain about them, which in our terminology is very statistically significant. So we are very certain about these effects. There's nothing, in empirical research, there is not 100% proof or certainty, but we have high certainty, and I think this can be conveyed.
Okay, and we'll take the last question at the back. Sorry, Rosalind, we'll come back to you later.
Hi, thanks very much for the talk. I was just wondering, your point about the WHO guidelines set out in 2021, were you suggesting that evidence published since then maybe indicates that even they are too high?
No, I wouldn't say they are too high. Actually, the levels that the WHO suggests, they say also that they are not thresholds. It doesn't mean that below that there are no effects. Just below that, we don't have enough evidence because we don't have levels in the real world to study. No, I think that the evidence after the air quality guidelines were published actually adds support to these levels that have been publicized. I think they are good targets for us in Europe especially to try to achieve.
Okay, we'll move on. Thank you, Claire. Thank you very much.